10-3 multiplying polynomials. All right. Now this starts us kind of like yesterday where we multiplied at the very beginning and then we factored. Well, today we're multiplying, and then when we get to 10-4, we start factoring. And these polynomials are a little more complex than the ones we've been dealing with. Okay. So first, I know a lot of you have seen this method where you multiply this times this using a box. How many recall that from 8th grade? Okay, I want you to go ahead and multiply it out right there. Right? Do your best on your own. See what you remember. All right, now that you've matched it up with your neighbor, you may feel more confident. You may feel a little less confident, okay? We're checking it out. This is just an area model. You're looking at x, a rectangle, well, in this case a square, that's x by x. Okay, as dimensions of x by x. To define the area of this square, it would just be x times x, which is x squared. And you have this rectangle here that has a length of 5 and a width of x, and so 5 times x is 5x. And you have this area right here that has a length of x, and then this is -3. Now we know we can't have a negative length, but if we're following along with the pattern, x times -3 is -3x, and then 5 by -3 is -15. Now how many filled it in correctly? Okay, so what we have now is we take our like terms and our unlike terms, we kind of put it in order from standard form. So in this case, the highest degree is x squared, and then we have our x's to the first. We have a -3 and a +5, so you could either add them here or you could write it out like this and then simplify it later. And then we have our constant there without the variable. So if we write it like this, then we'd have to go one more step and simplify. -3 plus 5 is +2 minus 15. That is our standard form. When I multiply this by this, I get that. Okay, that's using the box method. All right, any questions there? Okay, what I want you to do is spend time on the next 5 problems there using the box method. Okay, go for it. Get the next. Good deal.
Don't give me a high five and say it's wrong.
You didn't simplify it.
How was I supposed to?
Yes. We are not being very good.
Right here.
Yes.
Ooh, that's pretty intense. Pumped about that.
Wow. And they made a simple mistake.
What? Changing the log back. I know.
Yes, that
All right, let's check them out.
really?
Yeah.
Very good. We have our x squared, good, -2x, 18x, and -36. Well done. That gives us +16 right here. Good. Nice job, Jake. Well done. And Audrey. All right, and here, x squared, and 4x, and x, and 1 times 4 is 4. Very good work. Way to go, Mackenzie. And Lily helped out, yes? Good. All right. Who was it? Was it Caden helping? Oh, I'm sorry. All right. Hey, what happens when we get some other numbers in there? Well, we kind of do the same thing, right? So check your work here. We have 2k times k, which is 2k squared. k times 6, or 6k, 2k times 7, or 14k, and 7 times 6, or 42. Combine them, we get 2k squared plus 20k plus 42. All right. Any questions? Okay. Check this one. 6a squared. 3a times 7 is 21a. 2a times 4 is 8a. And 4 times 7, 28. 6a squared plus 21a plus 8a plus 28. These two combined give us 29a's. All right. Now we think they're good on the box method there. Okay. So just keep in mind on this one, you get a negative and a negative. That's a positive. Okay. And then, oops, sorry. Negative, negative is positive. E or y squared, negative 5y and negative 5y. So y squared minus 10y plus 25. Well done. Now there's if you don't want to draw the box, we could use what's called the distributive property. All right? So I'm fine with you using the box if you want. However, on the next set of problems there, if you look at this guy here, we could just use the distributive property. The distributive property works like this. Really, when you're multiplying these things, if we kind of reference this first problem we did, really what you're doing is you're saying x times x, that's our first thing, gives us x squared. And then we're multiplying this x also by the 5. Or, excuse me, we have the x. So x by x, and then x by negative 3. So you're multiplying this by that and by that. It's negative 3x. So it gives us both those terms. You could then go 5 times x, okay, and then 5 times negative 3. So 5 times x is 5x. 5 times negative 3 is negative 15. That'll give you the same pieces that you had here. Okay, so rather than doing the box every time and having to draw a box, you could go through the process of saying, well, I'm going to multiply this by that. That's x squared. I'm going to multiply that by that. That's 3x. I'm going to multiply that by that. That's 1x. And that by that, which is 3. Now notice I make two different rows. This row was the first thing I multiplied. This row is the second. And I actually stack my like terms. That way when I go to add it, no other x squared. There's 4 x's, and there's positive 3. That's called using the distributive method, distributive property. Some people call it FOIL because you have first times first times outer, you have your inners, and then you have your, you have your first times first. You multiply your outers, which is here to here, and then your inners, and then the last. Okay, I don't call it FOIL because it doesn't work on trinomials later. Okay? All right, everyone try these two using the FOIL method. Okay, I'm fine with using box later on, but I'd like you to try using FOIL right now on those two. All right, showed your neighbor that you're trying to use FOIL and not the box. Not that I'm against you using the box method, but I want you to try FOIL method right now. Okay, so here we go. X times x, x squared, check your work. X times 2, 2x. 4 times x, 4x. And 4 times 2 is 8. All right, check it out. We get x squared, 6x, and 8. All right, how many got it? You're good. Any questions? All right, we'll check that next one. B times b, that'd be b squared. B times 1, that'd be negative b. 6 times b, that'd be 6b. And 6 times negative 1, that'd be negative 6. Add them, b squared. 5b's and negative 6. Questions there? How many got that one? Alright. Let's go ahead and try that next row there. Give it a go. This next three, I'll be walking around. If you need help, make sure you get it there. Get that to focus for you. Well, that end one doesn't want to focus. So I'm going to put up this next one. We'll check it. See if you get them. That's 6k squared. That is negative 6k. That is 6k. And that is 4. Or, excuse me, negative 6. 6k squared. Plus 0k, so that part's gone, minus 6. How many got that? Good. Any questions there? Okay, on your paper today, your assignment is to finish through this part down here, right here. Okay, we're going to do these three as our intro tomorrow. Okay? Questions? All right. Very good.